Quantum computers are devices that make use of phenomena that is unique to physics at a very small scale, and they work with ideas that are not so common for us to understand at a common scale. Therefore, it would be very difficult to put it in a few words how quantum computers work, but the main idea is that you make use of these phenomena that is very unique at a very small scale, which is usually termed in names of superposition, entanglement, and a few other words that I can throw around. But the main idea is that you basically use these phenomena at the larger scale and exploit them to solve difficult computational problems. So my current research is about developing quantum algorithms. We do not directly develop these quantum computers, but we assume that somebody else will develop them for us. And once they are ready, we will be ready with the algorithms that are needed to run on these quantum computers. Specifically, we are developing hybrid algorithms. And these hybrid algorithms include, for example, the use of one kind of classical computer and one kind of quantum computer. But we go beyond that. For example, this year we developed an algorithm that uses another quantum computer. So a combination of 3 different types of computers in one algorithm to solve a difficult problem. The Frankfurt Quantencomputer Baby Diamond is well named because you get the characteristics of the baby diamond from its name. Baby, because it's very small, in the sense it is learning to compute. It has only 5 qubits, which is not much. And diamond, because it is based in a diamond. The essential working qubits of the device are fitted in a diamond, and therefore the name baby diamond. Science is considered better when it is direct and precise and has or knows its limits. In contrast, art is considered better when it is imprecise and indirect and does not know limits. So already at this point, we see there will always be friction when you take a physics model or a model from science and want to fit it to a model or compare it to a model in art. And if we take feelings, for example, as something that you model an actual thing on the inside, then yes, then this might be a suitable analogy to say there is the nature out there. You use quantum physics to model it. There is something inside you that you call a feeling, which is a model of that thing. And then you are at the same level to compare these two things. But if you take it literally, in the sense that these two, the description of nature and nature itself, are the same thing, the feeling anger and what you're feeling are the same thing, then this analogy does not fit anymore and you produce more paradoxes that one can avoid. But if we take this from the perspective of what Libby Heaney is doing, which is to say we can take this model and the other model and compare the two, then I think the analogy fits very well. So as a person who develops quantum algorithms, we are definitely anticipating very positively the coming of modern and future quantum computers so that we can finally test those algorithms on the large scale, because we show at the moment theoretically we can achieve some quantum advantage, but this quantum advantage can only be proven once you have an actual quantum computer that you can work with. And that is something that we are anticipating very happily.